Problem 12, where we choose 3 letters, then 3 digits, then 3 letters to form a license tag, was rated as one of the 2 most difficult problems. So let's think about this. Now there's a restriction on this problem that the 3 letters chosen first have to include a vowel. Let's ignore that restriction for the moment and just try to frame our understanding of the problem by just saying how many ways there are to just choose 3 letters, 3 digits, then 3 letters. Now, we're choosing license tags, so the order in which the letters and digits are chosen is important. Okay? Now, if we're going to choose 3 letters, and there's no restriction in the stated problem that says you got to choose them without replacement, clearly license tags can repeat letters. So it's most reasonable to say, well, we're going to choose 3 letters with possible repetition. So, well, there are 26 choices for the first, 26 for the second, 26 for the third. That's fundamental counting principle which applies here. So there are this many ways. Okay? And then 3 digits, well, there are 10 digits, 0 through 9. You can start with a 0 because this isn't going to be interpreted as a number. It's just 3 characters on your license tag, and there'll be 10 times 10 times 10 ways. Now, it's possible that on a license tag we might restrict the license tag from using 0 because it's too easy to confuse with an O, in which case there'd be 9 times 9 times 9, but there's no restriction on the digits, so we're going to assume 10 times 10 times 10. And then there are 3 letters, again, 26 times 26 times 26 ways. So, well, 26 times 26 times 26 is 26 to the third, 10 times 10 times 10 is 10 to the third, and so forth. So the number of possible tags is, well, we multiply the number of ways of choosing our 3 letters, which is 26 to the third, then our 3 digits, which is 10 to the third, then our last 3 letters, which is 26 to the third, and there are this many ways to choose a tag. Now, if you have the restriction that the first 3 letters, that's 3 letters plural, must include a vowel, how are we going to do that? Well, you can try reasoning that out. You know, well, let's see, the first letter doesn't have to be a vowel, so you have 26 possible choices. But if the first letter is a vowel, it is not a vowel, well, you could still have 26 choices for the second, but if the first is a vowel, that should make a difference. The problem in reasoning the number of ways these letters could be chosen to include at least one vowel is complicated by the fact that the number of ways to get this last character depends on whether a vowel was chosen in one of the first 2. So that there are maybe only 21, well, you might have only 5 ways to choose this last letter if you chose consonants on the first 2. So it all gets kind of complicated and the fundamental counting principle won't apply. So it gets difficult to reason this out, although it can be done. So you got a lot of contingencies though, and it's kind of complicated. We can cut through the complication by the fact that if your first 3 letters contain at least one vowel, that's equivalent to saying that the first 3 letters can't all be consonants. Okay, and we can say how many ways there are to get all 3 consonants. That's 21 times 21 times 21, because there are 21 consonants. Okay? Then the number of ways to get at least one vowel is going to be the number of ways to choose the 3 letters, which is 26 times 26 times 26, or 26 to the third, minus the number of ways they could all be consonants. Because if you take all the possible choices and eliminate all the ones that are all consonants, what's left is 3 letter choices that contain vowels. Okay, you're left with the choices that contain at least one vowel. So there are this many ways to get at least one vowel. Okay, this many ways to get all consonants. Subtract that from the total number of possible choices, and you get the number of ways to get at least one vowel. And you want to think about that a little bit. It's a very important principle, sometimes referred to as counting by counting what you're not counting. What we're not counting is the number of ways to get all consonants, but we count that and subtract that from the total number of choices to get the number of ways to get a vowel. We refer to this type of reasoning as complementary counting. We count the complement of the set of all choices that are all consonants. The complement of that set within the set of all possible choices is the set that contains at least one vowel. So that we call this complementary counting.